Alright, in this video I'll be going over the Test 2 review. On this first page I'm going to go through pretty quickly. I want to spend most of my time on the financial formulas. So let's go ahead and get started. You can see here we have right 2/5 as a percent. So to change a fraction to a percent, you're first going to want to change it to a decimal. To get 0.04 or 4/10, you just divide 2 by 5. And you can do that on your calculator. And when you do that, you get 0.4. If we move that decimal 2 to the right, we get 40%. All right, let's move on to the second one here. So notice here it says right as a percent. So just like in the last problem, once we have a decimal, we just move the decimal 2 to the right. And you can see that I did that. And you get 3.51%. Let's go on to the next one. So here we're going to write 175% as a decimal. The first thing my mind says is, hey, this is more than 1, because remember 1 is 100%. So remember also that the decimal is after the 5 here. It's 175.0. So when we move that decimal 2 to the left, which is what we do when we're going from percent to decimal, we get 1.75. All right, let's move on to number 4. Notice here, this is the one that students tend to miss. 1/4 can be written as 0.25, so this is 0.25% or 25 hundredths of a percent. So that's less than 1%. And so when we move that decimal 2 to the left to change to a decimal and drop the percent symbol, we get 0.0025. All right. On number 5, it says Justin's getting a 4% raise in his monthly salary. If he currently earns $3,500 a month, how much is his raise? So we want to find 4% of 3,500 or 3,500. So this is actually what I call the percent equation, or part of it. And this is the most common thing that we do with percents. We take a percent of a number. And so remember, in mathematics, of indicates that we're going to multiply normally, quite frequently anyway. So here we just want to multiply 0.04, the decimal form of 4%, times 3,500, and we get $140. All right, let's move on. So in this problem, it says Steve spent $12.40 on his lunch before tax. If the tax was 8.2%, find the cost of the meal. Notice it's not just asking for the tax, it's asking for the cost, and that's to the nearest cent. So first of all, to figure the tax, we're going to find 8.2% of $12.40. So again, we're going to multiply here, and when we do that, we get 102. Now, the total cost of the meal just includes the tax. Don't forget, we also have to pay the $12.40. So when you add those two together, you get $13.42. All right, let's look at number 7. It says 30 is 24% of what number? Well, in a problem like this, you can literally just translate this into a mathematical equation. We're looking for some number. It says 30 is 24% of some number. Remember, when you take a percent of a number, whatever follows the word of is the whole. So what we're really finding here is the whole. That's the number we're looking for. And what we have here is the part. And so we're expecting to get a bigger number. And so here's my equation. 30 is or equals 24%, we write as 0.24 of what number, so times some number. So this is my whole. 24% of that gives me 30. To solve this equation, I want to get x by itself, so I divide both sides by 0.24. And you'll notice when I do that, you get 125. So again, I said, notice we were given the part and we had to find the whole. And I just would remind you that the percent equation, basically it's percent of whole equals part, or percent times whole equals part. So we can do the same kind of thing on number 8. 18 is what percent of 48? So first of all, x is going to be the percent. Notice that's what we're looking for. So we have 18 is or equals what percent, that's what we're calling x, of or times 48. And so this is the equation we need to solve to find out the percent. So that's what I've done over here. You have 18 equals 48x. To get x by itself, since you have 48 times x, the opposite of multiplying by 48 is dividing by 48. And so we're going to get x equals 18 divide 48. When you do that, you get 0.375 or 375 thousandths. Now remember, this is a percent, so we want to write that as a percent, 37.5%. All right, on number 9, we have a 55-inch TV that's 40% off. If the regular price is $275, first of all, we need to find the discount. Well, if it's 40% off, we need to find 40% of this. To start, that's going to be our discount. So we're looking for 40% of 275. That's going to be 0.4 or 4/10 times 275, which is $110. Now remember, that's just the discount. For the actual sales price, you take what the regular price is and you subtract the discount, and that gives you your new price, the sales price, $165. And I'm surprised you can't, oh, you can't see that. I'm sorry, let me move this. There we go. So it was $275 originally minus a $110 discount. And so that's your new price, your sales price, which is what we were asked to find. All right, let's look at number 10. So it says if Maria borrows $3,500 or $3,500 from her Uncle Vito for 4 years and pays a simple interest of 7.5%, how much interest will she pay for the 4 years? Notice we're dealing with simple interest and we're finding the interest after 4 years. Well, we have our basic interest formula. It's I equals PRT. And so in this case, P is 3,500. That's the starting amount, or we call it the present value. There we go. And our decimal is 0.075 for the 7.5%, and the time was 4 years. When you multiply that out, you get $1,050, and I did it again. I thought my camera was covering, but it's not. Let me go up a little bit. I'm going to have to move this. Okay, so here's our equation. Principal or present value times the interest rate times the time. You get $1,050. On part B, notice it says find the loan's future value or the amount Maria will pay Uncle Vito in 4 years. Well, don't forget she's got to pay back what she borrowed plus the interest for 4 years. And so you could do this one of two ways. The easiest way is to take what you already have, the interest, and add it to the 3,500. And boy, that's just barely visible. And so you get 4,550. Now we do have a formula for future value. It's this one here, and that's when you're dealing with simple interest. So you also could have used that formula and you get the same answer. But since we already knew the interest, it was pretty easy to just add that to our present value, or our P. All right, let's go ahead and move on to the next page. All right, so I'm going to go ahead and get the formula sheet here. And I just want to point out, because one of the important things is that you know which formula to use for which situation. So notice we have just a couple of, actually there's two simple interest formulas. That's this one and this one here. We have the percent formula we already talked about. It's really the percent equation. This is the formula to figure out simple interest. This is the formula to find the future value when we're dealing with simple interest. These are equal. You can use either version. And then now notice we're moving into compound interest. So we'll get to those, but for now we're dealing with problems where we're dealing with simple interest. So it says, how much should you invest now at 7% simple interest to have $2,500 in 3 years? In other words, find the present value P. Well, let's go ahead and write the formula that deals with simple interest, because that's what we're dealing with here. We have A is equal to P times 1 plus RT. So in our problem, first of all, if this is the amount that we want to have in 3 years, that's our future value, or A. Notice it says, how much should you invest now? That's going to be your present value, or your P, the starting amount. Our time is 3 years, and notice we're at a 7% interest, so our rate we would write is 0.07. So we're going to put in our 2,500 here. We need to find P. It'll be 1 plus 0.07 times T, which is 3. And so I'm going to go ahead and rewrite this over here. You're going to get 2,500 is equal to, and when you multiply this out, let's see, you get 1.21. So it's 1.21 times P. So this is the 1.21, and this is our P. Now I'm just going to go ahead and write it on the other side. Now we're trying to solve this equation, so we have 1.21 times P. To get rid of the 1.21, we do the opposite of multiplication and divide. So when we get that solved, we're going to get P is equal to, and I got $2,066.12. All right, look at number 12. It says you receive an inheritance of $20,000 and invested in an account that pays 6.5% compounded monthly. Actually, let me turn my phone off so you don't have to hear that. Okay, so this is compounded interest. It's compounded monthly, so we know that N is 12. Notice the inheritance is $20,000, and that's what we're investing, so that's our P. Our interest rate is 0.065. It says, how much to the nearest dollar will you have in 40 years? So that's kind of nice. You're going to just throw that into an account for 40 years and see, and just let it grow. So our time is 40. So this is compounded interest, compounded monthly. Notice it's a one-time lump sum that we're putting into this account. It's not like an annuity where we're making regular payments. So we go to our formula sheet, and it's this one here. Future value for compound interest paid N times per year. In our case, our N is 12. Now, if it was paid once a year, we would have used this formula here. So this is the one we're going to use, this one here. So we have A is equal to P times 1 plus R over N to the NT power. So our starting amount here is $20,000 times 1 plus our interest rate, which we'll write as 0.065, divided by N, which is 12, to the NT power, that would be 12 times 40. And so let's go ahead and plug that into the calculator. Right there. So it'll be 20,000, parentheses 1 plus 0.065, and then hit the fraction button. Put in 12 and arrow right. End of parentheses, make sure you hit the exponent button. That's this button right here, the caret symbol. And we'll put in 12 times 40. I normally like to arrow out of there, and then I'm going to go ahead and hit enter. And I get $267,392.05. It looks like we are to round to the nearest dollar though. So this will be $267,392. So it says find the interest that you will have earned. Well, you only deposited $20,000. 40 years later, this is what it's worth. So if you take the $267,392 and you subtract the $20,000 that was originally invested, your interest is $247,392. All right, let's move on. So on 13, it says you would like to have $50,000 in 6 years for a down payment on a house. How much will you need to deposit now in an account that pays 7.5% compounded semi-annually to meet your goal? So first of all, this is compounded interest, but it's different than the last problem. This is what we would like to have in the future in 6 years. That's going to be our future value. How much will you need to deposit now? That's going to be your present value. R here is 0.075. Notice it's compounded semi-annually. That means twice a year or every 6 months. And so let's go to our formula sheet. So notice here, we just used this one, whoops, future value for compound interest paid n times per year. We're basically using the same formula because we're dealing with a lump sum. And we've got this financial goal. We want to have $50,000 in 6 years. So the key here is we're not making payments like monthly or yearly payments. So it's not an annuity formula. It's going to be this one here. I mean, there's two basic formulas when the interest is paid n times per year. It's either you're finding the future value or you're finding the present value. We're looking for the present value because we want to know what we need to invest now so that we'll have $50,000 later. So I'm going to go ahead and write that formula down. So that was P equals, it's going to be A over 1 plus R over N to the NT power. All right, so let's go ahead and plug in our numbers. We got 50,000. Let me move this up higher for you guys. That's over 1 plus 0.075. That's 7.5% interest over N. Remember, that was 2. And then NT, that would be 2 times, in this case, 6 years was RT. T was 6. And so this is what we have to plug into our calculator. Let's go ahead and do that. So I'm just going to go ahead and clear what I had. So I need a big fraction, and then we'll have this all in the denominator. So let's go ahead and hit the fraction button, and then 50,000. And then in the denominator, we've got 1 plus 0.075. Hit your fraction button, and then 2. Arrow right, parentheses. Don't forget your exponent button. Again, that's this one here, the caret symbol. And let's see, that's 2 times 6. You could just put in 12 here. We can multiply that out. And so when we hit enter, we get $32,144.95. And we normally would write it to the nearest penny if it doesn't tell us to the nearest dollar, because we're dealing with money here. So it's $32,144.95. So that's what you would have to invest now so that you would have $50,000 in 6 years. So that's making you some pretty good interest. Of course, that's at a 7.5 interest rate, which is not something you could find right now, not very easily anyway. The other thing I would have you notice is if you, this is what you paid. If you subtract that from 50,000, that would tell you what you actually earned in interest if you were asked. Number 14 says find the effective yield to the nearest 0.1% of an account paying 4.8% compounded quarterly. So basically what we want to do is figure out what would be the simple interest rate that you earn in a year, so that if we wanted to compare different loans, and maybe one's compounded quarterly, another one's compounded monthly, we could compare the loans by looking at their simple interest rate, or what we would actually earn in a year, what percent we would earn. Okay, so let's go ahead and write the formula for the effective yield, effective annual yield, annual, that's in a year. So y equals 1 plus r over n to the n power minus 1. By the way, when you show your work for some of the problems, this is what I would like to see. You don't have to write out the formula, but I find that you're less likely to make mistakes if you write the formula and then plug in the numbers and then put it into the calculator. If you get this far, you're going to get at least half credit. So that way I can see exactly what you were doing, and I can tell, oh, they made an entry error. So make sure you show your work in detail. All right, so in our problem here, we are going to have 1 plus the interest rate. We're going to write that as 0.048 divided by n. Notice it's compounded quarterly, which means n is 4, to the 4th power minus 1. And I'm going to assume that you can get that into your calculator, and you should get 0.04887. I like to write a lot of decimal places. And then let's move the decimal 2 to the right, and we can write this as 4.887%. But it says to the nearest 0.1%, so we're basically cutting it off right here. So we'll round that 8 up 1, and so this becomes 4.9%. Now you may want to round it maybe to 2 decimal places if you're trying to compare rates, but here we're rounding to the nearest 0.1%, so that'd be 4.9%. All right, let's move on to number 15. Says your friend's going to deposit $500 a month for 6 years into an annuity. So the fact that she's making regular payments tells you that it's annuity, even if it didn't say it was, in which the interest is 7.5% compounded monthly. Notice each month they're putting money into this fund or account, and it's also, the interest is being compounded monthly. And that's how it normally works. It says, how much to the nearest dollar will she have for a down payment on a house in 6 years? Let's go to our formula sheet. So here, excuse me, this is our first annuity formula, the future value of an annuity compounded n times yearly. So notice P is that's your monthly payment. In 6 years, I think that's what we're looking at here. That's going to be the future value, which we call A. And so that would be the formula that we want to use. If you had a problem where you were trying to find what your monthly payment needs to be, you would be using this formula. Notice it's an annuity. Annuity payments in times per year for financial goals. So here you have, that's if you have a goal. Maybe you want to raise $50,000. You want to know what you need to put into the account per month, or whatever N is. It could be per year. We've been doing mostly monthly. I think you might have seen one that was quarterly. So, but this is our formula here because we know the monthly payment amount. That's going to be our P. So let's go ahead and write the formula down. Let's see. So A equals, it's P times, parenthesis, 1 plus R over N to the NT power minus 1. Into parentheses. Now I use brackets, but they're really just parentheses. It just makes things stand out a little bit better here. And this is all over R over N. So our P here is the 500. That's our monthly payment amount that we're putting away. 1 plus our interest rate, that was 0.075. That's our R. N here, we said it was compounded monthly, so N is 12. To the NT power, that'd be 12 times, and it's 6 years. That's our T. Don't forget we have minus 1. The minus 1 is not in the exponent. And this is all divided by 0.075 over 12. So that's what we need to plug into the calculator. Let's go ahead and do that. So we've got, let's do the fraction button first, and 500 double parenthesis 1 plus 0.075 fraction, and we're going to divide by 12 here. End of parenthesis, exponent button, 12 times 6, which you might have just put 72 there, and then arrow right and subtract 1 into parentheses. So that's your numerator. Let's go down to the denominator. By the way, you can see what we've typed in, and so far everything is looking just like it does on paper. Now we can't see here unless we arrow right. So in the denominator we got 0.075 fraction, that's over 12. And I'm going to arrow to the right side of the fraction. And again, you can double check your numbers and hit enter. And we get $45,289.39 to the nearest dollar. So this is going to be $45,289. So in part B it says determine how much she contributed and how much interest she earned. Well, remember she's paying $500 a month, that's 12 times a year, for 6 years. If you multiply that, you get $36,000. So that's what she contributed, but it was worth $45,289. If you subtract $36,000, you can see their interest earned was $9,289. And so that's a nice chunk of change in interest. All right, let's move on to the next page. I'm going to actually go ahead and stop the video here, and I'll make a second video.